Hey guys, welcome to another video. Today we'll be uh, learning a new topic. It is called Morris Traversal. Yeah, let us write the code how the Morris Traversal works. See, it is the what you call um, iterative way of traversal of in order. First of all, let us try the Morris traversal in order traversal. Okay. What it helps is that the space complexity is reduced by big of 1. Okay, so for the Morris traversal, one thing you have to understand is that our threaded binary tree. Okay, before going to the left, we go to the left's most right guy and then thread it to the root. Then we go to the left. um, then we go to the left and then uh, and we go left. Then we see whether the if the left has null, then just print this. See, two cases comes. First case is that we have um what we have our left as null. Yeah, left as null. Then we print the element and we just move on. Yeah, we go to the right part. Got it? If it has left, when we get the rightmost guy and we thread it to the thing. Okay, so let us start it by writing what let us write a vector int dance. Okay, and we need also a current node. Let us quickly try to copy and paste. Okay, let us call it now Morris Traversal. Morris in order. Let us write. Okay, in order. Yeah, where we pass the root. Got it. Void we'll just print it no matter. Node star root. Yeah, what I told you that we need a let us write a node star current or root only. Current is our root. Okay, well, current is not null, we just if current's left is null, then we just see out roots value. Let's play a song. So let us complete it. What you have written is that if the left part has null, just print that roots data and move on to the what do you call, yeah, current equals currents, what do you call, left part, yeah, all right, but sorry, yeah, else that means our left part is there, um, and else means the left part is not null. Okay, we make a previous, which is currents left. um Current left is not null, while currents right is there, as well as currents right doesn't point to current or previous. I think previous, because previous is currents. What? Hmm. Okay. If this thing holds, then we are just moving to the rightmost guy, that means previous is previous, right, yeah, rightmost guy we have got. For example, there is two cases. One is that the previous right, yeah, is null, else other case is that it's pointing to the current, yeah, pointing to current. Okay, if it is a null, if it is a null, if the right is null, just point it to the so the threading is done. Threading is done. Threading is done, matlab we have given the path. Now we can move to the left part. If it is pointing to the current, that means already existing, to just remove it, that means current or previous right null cout roots data and move on to the right part. I think I am done. No, it is iterative. Why are you this? Let's see. Uh, where is it? Where the error is? Use of this. Wait, wait. Where did I use? Not getting it. Right. Oh shit. Okay. Current is null, then move to this current's left part is there, not there. Print that element and move on to the right part. Yeah. Else as left is there. Call it previous. Current's left, while previous is right part is there. Doesn't point to current, and we adjust the previous right, and then if it shows null, then we point it to the current, and current should point, then current point to the left. Move on to the left part. Else, pointing to the current, remove that, print that element. Yeah, and then I think we will be move on to the right part. Why it is not printing? I don't know. Oh, Okay, sorry. Sorry, very, very sorry. We are just printing the roots data. But no, we have to print currents data. Because current is our now root. Yeah. Wait. Previous is right. Currents right. Wait. Okay, got it. Yeah. It's not current, it is previous. See, um, if you do dry run, you will understand is that we are going to the rightmost part as the previous. So previous is right, should not point to the current. Yeah. Now what happened? What? What the error? Why, bro? What is this? PT host. Now what error, bro? Where did I use a vector? It's way bad, bro. I don't understand, bro. I don't know, man. What happened? What? Crashed or something? What is this? I don't know, man. Let's move on to like Morris. Practice. That's how we can do this Morris traversal. What we have done, we made a vector where we'll be storing the values. Yeah, like printing. We can print also, like printing. We can say store them. Okay, we make a current pointer which is pointing to the node, and while it is not pointing to null, then we just moving to the like. If see, one case is there, think about cases what would happen. Yeah, the left part is not there. Okay, I'm thinking of case where the left part is not there, so we're printing that element and move on to the right part. Yeah, like printing that element and moving to the right part. Else means left part is there, left part is there. That means we can uh, we can make a loop. Yeah, we can go to the rightmost part. Yeah, when until it is null. Yeah, okay, until it is null we move on to the right part. And also you have to see that the right parts, that is the uh, previous is right part, because we are making the previous pointer. Okay, which previous pointer is the left part, and we moving previous to the what rightest most part. Yeah, and then previous will be the rightmost part node. Then if it is pointing to null, then the previous right, then we just have to point it to the what you call current. Yeah, point it to current. And then we can move to the left part. Else means see, else means see, not null cases are done, so can be like that it is already pointing to the current. Then we have to remove, that means previous right should point to null. And also we push that root, that means current's data, and we have to just move to the right part and we just return it. And that's how we got the Morris traversal. Next, let us solve another question on our. It is question number 114. It is a flatten binary tree to linked list. Okay, flat it. So we are gonna solve it by recursive way. Okay, recursion, by the recursion. Okay, let us do it. This is very easy. Okay, how are we gonna do this? See, we will be moving like in order. Okay, we'll be moving pre-order series, pre-order series, but from the end only we will make. Yeah, so from right, then we move on to the left, then root. Okay, we need a previous, which is null, let us say, for example, now. Yeah, global world. If root is null, then return otherwise called roots right part, then roots left part, yeah, and the roots left part will be null, not equal, and roots right part will be what? I think previous and last previous go. We have to change the previous only, yeah. Previous would be root. Right. How it is gonna help? Let us take for example this case, okay. If you see 1 2 3 4 5 and 6, yeah, root is not null, so call the right part, again right part, move on to the rightmost part, right is null, return, left is null, return, right left done, then its left part should point to null and the right part should point to previous, that is also null, and previous we are changing to the root, that is our, in this case is 6 I think, yeah 6 is our previous now, yeah. And then again you have to just return to 5 is right done, left is also null, then again return, if both are done then left part should point to null and the right part should point to 6, it is okay, yeah. Then previous would be changed to our 5, then you move on again to 1, yeah, move on to the left part's right part, that is 4, yeah, 4's, then again right part is null, return, then you got 4 as our root, then we left part is pointing to null and the right part should point to previous, and previous is our 5, so it should point to the 5, yeah, and previous should be changed to the root, that means 4. Then again we move on to the return to left part, yeah, left part is 3, then right part, left part, then this is 3 only root, 3 is left point to null and the right part should point to the previous, that is 4, and then we return to 2, left part right part done, left part should point to null and the right part should point to previous, that is our 3 I think, yeah. Then change it to 2, then again you return to 1, left part should point to null and the right part should point to previous, that is 2, yeah, and previous is equals to 1, yeah, and again for 1, it's done. That's how you solve this type of question. Thanks, hope you liked the video. Subscribe this channel for more videos. Bye.